Question number 8. Two fair dice are thrown. Let the random variable x be the smaller of the two scores if the scores are different, or the score on one of the dice if the scores are the same. Copy and complete the following table to show probability distribution of x. Okay, so you're throwing two dice and you're recording the smaller score. And if by chance you get the same score on both the die, then your score is the one of those values. Chaji. So now how do we show all the outcomes? Copy and complete the table to show the probability distribution of x. So 1 means that the score is 1. When will the score be 1 if you throw two dice? When there's 1 at the top of both the die. Only then the smaller score is 1. So both the dice should give you 1. So what's the probability of getting 1 then? 1 by 6 times 1 by 6. Oh no, there's so many other cases where you get where the smaller number is 1. For example, you have 1 on one of the dice and 2 on another dice, or 1 on one dice and 3 on the other dice, or 1 on one of the dice and 4 on the other dice, and so on. So there are so many outcomes in which your score is 1 because you're choosing smaller of the two scores. So
सारी हो जाएगी, 7 पॉसिबिलिटीज हो जाएगी.
7 हो जाएंगे.
नहीं, मैं 13.
13 हो जाएंगे. अच्छा. Now a good way of doing this question is by using possibility diagram. So what I'm going to do, I'm writing the result of the first row here, 1, 2, 3, 4, 5, or 6, and the result of the second row here, 1, 2, 3, 4, 5, and 6. This way we'll be clearly able to see how many total outcomes are there, and we can clearly see all the outcomes in front of us. Okay, so when you get 1 and 1 on both die, you get 1. When you get 1 and 2, it's 1, 1, 1, 1, 1, because you choose the smaller number. With 2, 1, it's going to be 1, 2, 2, 2, then 2, 2, 2, and 2. Then with 3, 1, it's going to be 1. With 3, 2, it's going to be 2. With 3, 3, 3, 3, 4, 3, 3, 5, 3, 3, 6, 3, because we're choosing the smaller score. Then 4, 1 is going to be 1, 4, 2 is going to be 2, 3, and then 4, 4, 4. Then 1, 2, 3, 4, 5, and then again 5, and 1, 2, 3, 4, 5, 6. Okay. So now, how many times is the smallest score 1? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the probability will be 11 by how many total outcomes are there? 6 by 6. 6 times 6, 36. So the answer for the first one is going to be 11 by 6. Sorry, 11 by 36. 11 by 36. Okay, how many times did we get a 2? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 by 36. Then 3, 1, 2, 3, 4, 5, 6, 7. 7 by 36.
तो फिर 2 से ही कम हो ही जा रहा है न्यूमरेटर इसका.
हाँ, ठीक है. Then 5 by 36. Then 3 by 36. And then 1 by 36. So by drawing the possibility diagrams, we've made our job very, very easy. Otherwise, I don't know At least I won't be able to do it without using a possibility diagram. It would take me a long time. Part 2. Find the expected value. So the formula for expected value in probability distribution is summation x times the probability. So it's going to be 1 times 11 by 36 plus 2 times 9 by 36 plus 3 times 7 by 36 plus 4 times 5 by 36 plus 5 times 3 by 36 plus 6 times 1 by 36, which gives an expected value of 2.53.
मैं एक्सपेक्टेड है किस चीज की?
ये स्कोर्स के 1 2 3 4 5 या 6 के जो हम 2 डाइस थ्रो कर रहे हैं उनमें से स्मॉलेस्ट वैल्यू चूज करनी है. तो सबसे
तो
इन दिस
चांस
सिनेरियो,
कितना है अगले स्कोर पे ये होने का?
सॉरी
तो जो नेक्स्ट टाइम इसको रोल करेगी टाइस को तो फिर यही आएगा, यही वैल्यू आएगी।
सॉरी क्या मतलब नेक्स्ट टाइम रोल करेंगे?
मैंने जो एक्सपेक्टेड वैल्यू वही वैल्यू होती जो लेके आ सकते हैं आफ्टर जो
हाँ, एक
इवेंट
तरह से
होने से होते हैं।
एवरेज है. एवरेज
ठीक
मीन
है
की
मैम।
एक फॉर्म है.
ठीक है मैम।
ओके. क्वेश्चन 9 वो सबमिशन वाला क्वेश्चन है विच वी डन इन ग्रेट डिटेल इन अनदर वर्कशीट, तो वो मैं नहीं करा रही.
ये मुझे
आई एम नॉट.
पहली वर्कशीट थी मेरे ख्याल से।
नहीं, पहली तो वो थी ना कम्युलेटिव फ्रीक्वेंसी वगैरह.
हाँ
वो
जी,
तो
तो उसमें नहीं
काफी.
थी मीन स्टैंडर्ड डेविएशन, उसी में थी ये।
हाँ, वो आई थिंक सेकंड टॉपिक था. फर्स्ट चैप्टर में मैंने 3 4 वर्कशीट्स कराई थी और उसके बाद आई थिंक सेकंड टॉपिक की थी सबमिशन वाली. ओके. क्वेश्चन 10. A box contains 5 balls numbered 1, 2, 3, 4, 5. 3 balls are drawn randomly at the same time from the box. By listing all possible outcomes 1, 2, 3, 1, 2, 4, etc., find the probability that the sum of the 3 numbers drawn is an odd number. All right, so first we have to write all the possibilities. There are 5 balls with 5 numbers written on it, and you have to take out 3 and list down all the possibilities. So first, let's see how many possibilities would there be. So there are 3 balls that have to be chosen. For the first ball, we have 5 contenders, then 4 contenders, and then balki 5C3 hoga, because this is selection, not arrangement. So 5C3 would be equals to 10. So there would be total 10 possible outcomes. So now let's list down those outcomes. So 2, they've already given us 1, 2, 3, 1, 2, 4, 1, 2, 5, then 1, 2, तो हो गया. Let's start with 1, 3, 1, 3, 4, 1, 3, 5. Now let's use 1, 4, 5. Then let's write the others here. उसके बाद we can use 2, 3, 4, 2, 3, 5. Then we can use 3, 4, 5, 3, 4, 5, 6, 7, 8, 9. Okay, 1 is still left.
एम 10 आगे मेरे वो नंबर्स।
Okay, let me just see which one have I missed. 3, 4, 5. I've missed 3, 4, 5. No, 3, 4, 5 तो है. I've missed 2, 4, and 5. So 2, 4, 5, and then 3, 4, 5. All right. So these are 10 outcomes: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Mm, Find the probability that the sum of the three numbers drawn is an odd number. So is the sum odd here? No, not odd. Odd, not odd, not odd, odd, not odd, odd, not odd, odd, and not odd. So 4 by 10 would be the probability. So the answer for this part is going to be 4 by 10. Okay. The random variable L denotes the largest of the three numbers. Find the probability that the largest number is 4. Okay. So this is the case where the largest number is 4. This is the case where the largest number is 4. And this is the case where the largest number is 4. So it should be 3 by 10. Okay. Draw up a table to show the probability distribution L. Okay. So
इसका टेबल कैसे ड्रॉ करना है क्योंकि इसमें तो 3 वैल्यूज हैं इंस्टेड ऑफ 2.
देखो largest value बतानी है. So what would be the probability when the largest value is 1? What would be the probability when the largest value is 2? When the largest value is 3? When the largest value is 4? And when the largest value is 5? We've already found the probability for 4. That came out to be 3 by 10. Okay. How many times, what's the probability that the largest value is going to be 1? 0. What's the probability that the largest value is going to be 2? 0. Now let's see when is the largest value 3? Here. I think that's the only case. Yep. So this would be 1 by 10.
वे ऐड अप होकर ये वैसे ही 1 हो जाता है.
Okay. ठीक है. And how many times is the largest value 5? 1,
6.
2, 3, 4, 5, 6. Yes, so 6 by 10. This would be x, and this would be probability x equals x. Okay, now we need in part 4 expectation as well as variance. So the formula for expected value is summation x times probability. So that's going to be 1 times 0 plus 2 times 0 plus 3 times 1/10 plus 4 times 3/10 plus 5 times 6/10. So that's going to be 4.5. Draw up a table. Acha, that is done. And now we need the variance. So the formula for variance is variance of x would be, in variance, we do not take a square root. And the formula is summation x square times probability minus square of the expected value. So that's going to be 1 square times 0 plus 2 square times 0 plus 3 square times 1/10 plus 4 square times 3/10 plus 5 square times 6/10 minus 4.5 square. Okay, no square root, which gives 0.45. Next question we're going to do is going to be question 11. Following table shows the result of a survey to find the average daily time in minutes that a group of school children spent in internet chat rooms. The mean time was calculated to be 27.5 minutes. Form an equation involving f and hence show that the total number of children in the survey was 26. So we're given mean, so we're going to use the mean formula, same as O levels. Midpoint times frequency plus midpoint times frequency plus midpoint times frequency plus midpoint times frequency divided by the total frequency 2 plus f plus 11 plus 4 equals to 27.5. Rearrange it, you'll get f on both sides, then you'll move it to the same side, get the value of f. Should come out to be 9. So f is 9, so then the total number of children would be 2 plus 9 plus 11 plus 4, which is 26. Find the standard deviation of time. So the standard deviation formula is, since it's group data, so it's going to be summation x squared, but instead of x, you're going to take the mid value. So the mid value squared times frequency upon summation frequency minus mean squared, and since it's standard deviation, we'll have to square root it. So it's going to be the mid value, the first mid value is 5, so 5 square times 2 plus 15 squared times f is now 9 plus 30 squared times 11 plus 60 squared times 4 upon total frequency, which is 26, minus mean squared. Mean is already given, 27.5 squared, which gives 16.1 after rounding. Question 13. In a competition, people pay $1 to throw a ball at a target. If they hit the target on the first throw, they receive $5. If they hit it on the second or the third throw, they receive $3. And if they hit it on the fourth or the fifth throw, they receive $1. People stop throwing after the first hit or after 5 throws if no hit is made. Mario has a constant probability of 1 by 5 of hitting the target on any throw, independently of the results of the other throws. Mario misses with his first and second throw and hits the target with his third throw. State how much profit he has made. So he paid $1 to play this game, and if he's hitting the target at the third throw, so if it's the third throw, he receives $3. So then that's a profit of $2. So 3 minus 1 is $2. Answer for part 1 is $2. show that the probability that Mario profits is $0 is 0.184. Okay. So when is the profit 0? That is when he gets the $1 back. He paid $1, and then if he hits the target at the fourth throw or the fifth throw, then he gets $1 back. So that's the case where he hits the target at the fourth throw. So hit. So first three are missed, and then there's a hit. And it says in the question that when you get a hit, you stop playing the game. So he stops here. Or if he hits the target at the fifth throw. So four misses and a fifth hit. In these two cases, he gets $1 back, making profit 0. So probability of missing is, probability of hitting is 1/5. So probability of missing is 4/5. 4/5 times 4/5 times 4/5 times 1/5 plus 4/5 times 4/5 times 4/5 times 4/5 times 1/5. This should come out to be 0.184 as stated. Correct to three significant figures. Okay. Draw up a probability distribution table for Mario's profit. Okay. So if he gets $5 back, then it's a profit of 4. So profit in the top row. So if he hits the ball at the first throw, then he gets $5 back and the profit is $4. So I'm going to start with the table with $4 profit. Then if he gets $3 back, then that's a profit of $2. And if he gets his $1 back, that's a profit of 0. And if he's unable to hit the target in the first 5 throws, he loses his $1. So that's a profit of -1. Now we have to find probability of each case. We already have one of those probability that was for making $0. So it's going to be 0.184 here. Okay. Now let's find the probability that he makes a profit of $4. So that is when he hits the ball at the first attempt. So first hit, that is a probability of 1/5. So 1/5 here. Then he receives $3 if he hits in the second attempt or the third attempt. So miss, hit, or miss, miss, hit for $2 profit. Okay. So miss is 4/5, hit is 1/5, or is plus, then miss 4/5 times 4/5 times hit, which is 1/5. Okay, this comes out to be 0.288. I've just written rounded off answers. I think it would have been better if I'd used fractional answers or at least 4 to 5 decimal places answers. But anyway. And then probability of making a profit of -1. That is when he does not get to hit the ball in the first 5 throws. So miss, then again miss, then again miss, then again miss, then again miss. So 4/5 power 5. Which is 0.328. Okay. Calculate the expected profit. So that is going to be 4. The formula is expected value is equal to summation x times probability 4 times 1 by 5 plus 2 times 0.288 plus 0 times 0.184 minus 1 times 0.328. 1.05. Next, we're going to do question 14. The salaries in thousands of dollars of 11 people chosen at random in a certain office were found to be this, and this. Choose and calculate an appropriate measure of central tendency, that is mean, median, or mode. To summarize these salaries, explain briefly why the other measures are not suitable. Do we use mean to calculate an appropriate average? Should we use mode as an appropriate average, or should we use median as an appropriate average? So mean is the best way of summarizing the data, but mean fails if there's an outlier in the data, which there is. All the other values are quite similar, except for this. This salary is significantly higher than the other salaries. So mean is not a good way of representing the data because 352 is an outlier. There's an outlier in the data. So you write that down. Okay. Then let's see what the mode is. Mode is the most occurring number, which seems to be 40. Is there anything else that's occurring more than once? No. So 40 is the mode. Now, mode is a good average if you don't have the option of using mean, but mode fails if the extreme value of the data is the mode. Like here, 40 is the smallest value of the data, and that itself is the mode. The biggest value of this data is 352. If that was also occurring twice, then also we would have said that it's not a good idea to use mode as the measure of central tendency, as the best way of representing the average of the data, because mode, it should be some value in the center, not extreme values. So since here 40 is an extreme value, so mode is also not an ideal candidate. And lastly, we're left with median. So since it's not a good idea to use mean, it's not a good idea to use mode, so you're left with median. So you write median after clearly rejecting mean and mode, and then find the median, uh, write the data in ascending order, and then choose the middle value. 40, 40, 41, 42, 45, 47, 48, 49, 50, 51, and 352. That's 11 people, so 11 plus 1 divided by 2. Sixth value should be in the middle. It's this value. So median is going to be 47,000. Remember to write 1,000 with the answer. So I think that's it. This wraps up the topic. बाकी आगे वही चीजें, either it's probability distribution, or it's binomial distribution, or it's normal, mean, median, mode. So we've done that already, and that brings us to the end of this topic. Now I think I will start geometric distribution tomorrow, or maybe normal distribution, depends. I need to make a worksheet for geometric distribution, so if I get to do so, तो कल वो कर लेंगे, वरना हम normal distribution ही करेंगे. ठीक है? Take care. See you tomorrow. Allah Hafiz.